Hey everyone, welcome back to school. I hope everyone had a restful Thanksgiving break. So I will be out of school today, tomorrow, and Thursday for a conference in Williamsburg with several other teachers and several administrators. I will be back in school on Friday. Please remember that you have a test on Thursday on the logic unit. So the purpose of this video today is to review a little bit of the logic unit with you and hopefully to get everything back in your memory. I know it's been a week since we've talked about any of this, so we're going to go through it today. So this first video is just going to be a review of the notes. There's a video that I would like for you to watch after this video finishes. It is also posted in Canvas and it is called Logic Practice Test. And on that test, the practice test, I've actually taken the real test and I've created a practice test based exactly on the real test. I have just changed around the words and the numbers a little bit. So I encourage you to take the practice test really seriously and to watch the video and to pause and take notes if you need to, because if you do really well on the practice test, you should do really well on the real test. Okay, so let's just go ahead and dive right in. The first thing I want to review with you are the symbols that we have learned in this unit, and these are on the test, so I encourage you to take a minute and pause the video and grab a piece of paper and take some notes along with me that will help you study for the test. So here are our symbols that we learned in the logic unit. The first one is just an arrow that points to the right, and that is just our symbol for if, then. And an example of something that you might see is if P, then Q. That's how that would be written. If P, then Q. The second symbol is the symbol for and that should be really easy to remember because it actually looks like an A without the extra line there. And an example of what you might see that, the way you might see that is P and Q. Our next symbol is the symbol for or. It looks like a V, but it stands for or. And an example of the way you may see that is P or Q. The next symbol is a double arrow, and that symbol stands for if and only if. It's also the symbol for a biconditional statement, biconditional statement. So if you see the double arrow, you know that the sentence should have the words if and only if, or the problem should tell you that it's a biconditional statement. And the way you may see that is P if and only if Q. Our next symbol, the three dots in the shape of a triangle, is the symbol for therefore. And an example of that would be therefore P. The next symbol is called a tilde. That's the formal name for the symbol, but in geometry it stands for the word not or negate. So if we're going to negate something, we're going to add this in front of the letter. For example, we could have if not P, then not Q. But we could also have if P, then Q. So both letters don't have to have the not symbol. The not symbol just means we're going to negate whatever the original sentence represented by the letter P is. And our last symbol we did not talk about in this unit, but it is on the test, and I know you've seen it before in other classes. This is the symbol for not equal. Not equal. So that covers all of our symbols. Again, you're going to have to memorize these. These are on the test. I believe the question that involves symbols, there are a couple of them, but I believe the big one is like a drag and drop question. You'll see that on the practice test. So the next thing that I want to review with you is a conditional statement also the inverse of a conditional statement, also the converse of a conditional statement, and the contrapositive of a conditional statement. So you're going to have to memorize these. There's no, they're not on a formula sheet. There's no good way. There's no good tricks. It's just going to be a memorization. The conditional statement, all a conditional statement is just an if-then statement. And it may or may not be true. It doesn't have to be true. It just has to be stated as if-then. And symbolically, that's going to look like if P, then Q. And so I'm just going to give you an example of an if-then statement. If it is cloudy outside, then it is raining. All right. So a conditional statement is just an if-then statement. It's just as simple as that. And we know this is not really true. Just because it's cloudy outside doesn't mean that it is raining. But we're going to use this as our example. So the inverse of a conditional statement is just we're going to negate the hypothesis and the conclusion. And the symbolic form for that is going to be if not P, then not Q. We read that if not P, then not Q. So going back to our original statement, let's take the inverse of that. The inverse would be if it is not cloudy outside. That is, we have just negated the hypothesis. Now we need to negate the conclusion. Conclusion is going to be then it is not raining. Now remember, if the word not is already in the original statement, to negate it, we would just take the word not out. To negate something means we're going to make it the opposite of what it currently is. So the converse is just going to be switching the hypothesis and the conclusion. So we're going to switch hypothesis and conclusion. And the way that looks in symbolic form is just we're going to take our if P then Q and we're going to make it if Q then P. So all I did is switch the hypothesis and the conclusion. The contrapositive, actually before we talk about that, let me do the example. Let's start with our original conditional statement. If it is cloudy outside, then it is raining. The converse of that would be if it is raining, then it is cloudy outside. So all I did was switch the hypothesis and the conclusion. And finally, the contrapositive. So for the contrapositive, we're going to switch and negate the original conditional statement. And in symbolic form, that's going to be not, if not Q, then not P. So using our original conditional statement, we're going to switch it and negate it, and we're going to say if it is not raining, then it is not cloudy outside. So I switched the hypothesis with the conclusion, and I negated both of them for the contrapositive. So again, you're just going to have to memorize these. There is an example of one, I think at least one example of one on. Okay, so that takes care of all of our conditional statements and the inverse, converse, and contrapositive and our symbols. Now let's go over and talk about the two laws of logic that we learned. The first one was the law of syllogism, and here was the map of the law of syllogism. And remember, the law of syllogism, the way you're going to know that apart from the law of detachment is that the law of syllogism is always going to give you two if-then statements. The law of detachment only gives you one if-then statement. And the way the law of syllogism works is that the conclusion of the first statement, which is represented by our Q right here, has to match the hypothesis of our second conditional statement, also represented by the Q here. Since these match, we can actually mark them out, and our conclusion will just be whatever's left over. Well, what is left over? P and R. So our conclusion, if these two things match, is going to be if P, then R. So let's go ahead and do an example. So our first statement in the law of syllogism example is going to be, if it is cloudy outside, then it is raining. If it is raining, then I will need my umbrella. I will need an umbrella. Okay, so since we have two if-then statements, we know that it's the law of syllogism. So what I need to do is I'm going to go ahead and underline the conclusion of the first statement, it is raining, and the hypothesis of the second statement, it is raining. If these two things match, only if they match, I can mark the whole conclusion out here and the whole hypothesis out here. And our conclusion will be whatever is not marked out. So if it is cloudy outside, then I will need an umbrella. Now this only works if these two things match. If this were to say it is not raining, then you cannot conclude that you will not need an umbrella. If these two things don't match, then there can be no conclusion. So if they don't match, your conclusion is just invalid. Alright, so now let's talk about the last thing, the law of detachment. And the way that looks, the map of that is you're going to have one if-then statement, so if P, then Q. Then the second statement is going to tell you whether or not the hypothesis is true. So let's assume that it is true. If it is true, if the hypothesis is true, then you can conclude that the conclusion is true. So therefore Q, which represents the conclusion. So let's just take a look at an example, and it should make a little bit more sense. So here I've written down a conditional statement. If you get in a fight at school, then you will be suspended. Alright, that's only one if-then statement. So we know just by that fact that it is the law of detachment. So then the next statement that they're going to give you is going to tell you whether or not the hypothesis is true. So we can say, Jake got into a fight at school. So with the law of detachment, I want to underline the hypothesis. You get in a fight at school. And the next statement, I want to see if that confirms my hypothesis. Jake got into a fight at school. Well, yes, that does match my hypothesis. So what I can conclude is, therefore, Jake will be suspended. That's what your conclusion will look like. And that only works if this statement verifies your hypothesis. If this said Jake did not get into a fight at school, then your conclusion would not be valid. You would just say no valid conclusion because it does not match or mean the same thing as the hypothesis of the first statement. Alright, that is all I wanted to review as far as notes. You do have all of this information in your notes if you would rather look at those. All of the notes are also posted on Canvas under the Logic module. So you can go back and review those as well. So now go ahead and go and watch video number 2. Again, it is called logic practice test, and that is going to look almost identical to the test that you're going to have on Thursday. It's just different words or different numbers.